This is the problem that we did not get to in class on Friday, so I decided to make a video of it. So in example 4, it's asking for the initial velocity for a bullet fired vertically from the ground level to reach a maximum height of 2 kilometers. Okay, so we know our position formula. It's given by S sub 0, which is the initial velocity, initial position, plus V sub 0 times t minus 1/2 g times t squared. And our velocity function is found by taking the derivative of the position function. I'm trying to record and write at the same time, so just bear with me. So to take the derivative, since the initial position is a constant, derivative of a constant is just 0. Derivative of constant times t, our variable, is just our constant. Minus, here we'll use our power rule, so we bring the 2 to the front, so 2 times 1/2 is 1, so I'm left with just gt. And so we have our velocity function. Okay, so the information given to us was that the max height equals 2 kilometers, which equals 2,000 meters. And we needed that because we're given that g is 9.8 meters per second. We're not worried about the 32 feet per second. Okay, so based on this information, what are we going to do? Well, I don't have a lot of information, but I do know max height occurs when velocity equals 0. So I can go into my velocity formula and set it equal to 0. 0 equals this v sub 0 minus g of t. And if I find what t is, well, then I can use my position formula and set that equal to 2,000, since that's the position of the max height. And my only unknown will be v sub 0. So that's the plan. So let's get t by itself. So here I'm going to add g of t to the other side so I don't deal with any negatives. So I get g t equals v sub 0. I want t by itself, so I'll divide by g, and so I get t equals v sub 0 over g. Okay, so now that I have something for t, I will plug it into my position formula. So max height occurs at a position of 2,000 meters. S sub 0, right, my initial position, since this came up from the ground level, that's 0, so I don't need to plug in anything for that. And then I have v sub 0 times t, and this is my t. And then it's minus 1/2 g times t squared. Now notice I did not plug in 9.8 yet for g. I think it might be easier to simplify this first before I plug in the 9.8, since I have a lot of stuff going on with these g's. So let's simplify this as much as we can before plugging that in. Okay, so let's work on this right-hand side only. So I have here v sub 0 squared over g, right? Just multiply those fractions. And here I have, well, let's just take the time to write this. This is v sub 0 squared over g squared. And so here I have in the numerator 1 times g times v sub 0 squared all over 2 times g squared. I can cancel out this g with one of these g's, and so in my numerator I just have v sub 0 squared all over 2g. Well, now when I subtract fractions, I need a common denominator. So this guy has a 2g, so we need a 2 down here, but whatever I do to the bottom, I need to do to the top. And so 2 v sub 0 squared minus 1 v sub 0 squared is just 1 v sub 0 squared all over 2g. And we said this equals 2,000. Well, now notice I simplified this all the way down so that I just have this 1g. So now I can plug in for g. I made it a lot easier. So 2,000 equals v sub 0 squared all over 2 times 9.8. And so I have a fraction equal to a number, so I will cross multiply. And so now my calculator, I will do 2 times 9.8 times 2,000, and that gives me 39,200, and that equals v sub 0 squared. But I don't want v sub 0 squared, I want v sub 0, so I'll take the square root of both sides. And so I get v sub 0 equals about 198 meters per second. I found the initial velocity. If you have any questions on this, make sure you ask me in class or come to Extra Help. Hope this was helpful.